further because we're moving into the 10th grade geometry. So we're going to go a little bit faster and go a little bit more in depth, but some of it you've seen before, so it should sound a little bit familiar, okay? So transformations. So a transformation is a change in the size. It is a change in the location or in the orientation. And orientation is a fancy word for direction. Like this arrow is pointing up. Pointing down just means a change of orientation. So orientation is just a matter of direction, okay? So again, a transformation is a change in the size, location, or orientation of a figure. So today we're going to focus on the location of a figure. So a translation is a transformation which slides each point of a figure the same distance and in the same direction. I cannot emphasize enough the word same. Every single thing has to go the exact same. If you're going to move 1 point 2 units to the right, you have to move all the points 2 units to the right. It has to be the exact same in order to be a translation. And so the resulting figure after a transformation is called the image of the original figure. Usually the original figure is called the pre-image. So you're going to get used to seeing that word a lot if you are hearing that word. All right, so let's get started with doing some translations. Excuse me. So we have triangle ABC is translated 1 unit right and 4 units up. Excuse me. So when it says draw the image triangle, this is read A prime, B prime, C prime. So this is the original figure or the pre-image. This is going to be the image, and it's the image after the translation. So we want to move every unit 1 unit right and 4 units up. 1, 2, 3, 4. I think I just said unit and I meant point, so I apologize. All right, so this is going to be B prime. All right, and so then again with C, we're going to go 1 unit to the right and 4 units up. 1, 2, 3, 4. And so this is C prime. And then I'm going to do the same thing with A. I'm going to go 1 unit to the right and 1, 2, 3, 4 units up. And this is A prime. So here we have triangle ABC, which has been translated 1 unit to the right and 4 units up. And again, notice that this figure looks exactly like this figure. It's just in a different location. That's what a translation is. All right, so now we're going to identify what these new coordinates are. So A, which was at 1, -3. A prime is at 2, 1. B prime is at 1, 2, 3, 4, 1, 2, 3, 4. And C prime is at 1, 2, 3, 4, -2. No, it's not. That was the original one. My bad. Sorry. It's at 4, +2. No, it's not. It's at 5, +2. Your math teacher can't count. My bad. So 5, +2. There we go. All right, so if you're looking at this, I know some of you are sitting here thinking in your head, do you have to count like this every single time? And no, you don't. There's actually a rule that, or a way that you can write this using kind of a translation rule. Excuse me. And so the way we write it, because we're going from triangle ABC to triangle A prime, B prime, C prime, is we're going to say XY is going to be X plus 1, because we're going 1 to the right and 4 units up is +4. So if you think about a coordinate plane, and this is your X and this is your Y, this is a positive X, this is a negative X, positive Y, negative Y. So here you're going to the right, here you're going to the left, here you're going up, and here you're going down. So you're going to use those general directions to help you identify this. So this is, if you look here, since we're adding 1 to the X and 4 to the Y, you should see that. We're adding 1 to the X and 4 to the Y. 1 to the X, 4 to the Y, 1 to the x and 4 to the y. Okay? All right, so, oh, actually, let me come back to this. I want to show you another notation. This is not in the packet, but I want to make sure you understand this because you're going to see this sometimes, and it is called vector notation. And you know how points are written x comma y? Well, with vector notation, you would write the translation inside these side arrows. For lack of a better word. And it kind of looks like a point, but instead of actually writing an X or a Y, you write what you did inside those arrows. So just to show you, this one in vector notation would be +1 and +4. And that shows me that I'm adding 1 to the X and 4 to the Y. And I'll do some more of those just so you'll see what it means or see how it looks. All right, so example 2 here, it says JKL has coordinates, so if right here, so we're going to draw these. So J is at 0, 2, and we always want to label our points. K is at 3, 4, and L is at 5, 1. And then, of course, we want to connect the dots. So we have our triangle here. So then it says draw a image triangle J prime, K prime, L prime after a translation 4 units to the left and 5 units up. So let me show you what this is going to look like. There's 2 ways we can write this. We can say x comma y is going to be 4 units to the left, means I'm going to go this way. That's to the left. So I'm going to subtract 4 from the x. And then 5 units up means I'm going to go this way, which means I'm adding 5 to the y. So this is one way of writing it. The other way is to say this, -4, 5. Sorry, I had to take a water break there. Okay. So this is the vector notation that I was just talking about. And this just means you're subtracting 4 from the x and you're adding 5 from to the y. So now we can look at these points here and just subtract 4 from each x. So 0 minus 4 is -4. And then we're adding 5 to the y. So 2 plus 5 is 7. 3 minus 4 is -1. 4 plus 5 is 9. 5 minus 4 is 1. 1 plus 5 is 6. So let's graph these and see if I added correctly. Okay, so we have -4, 7, negative, oh, and that is J prime. Then we have -1, 9, that is K prime. And then we have 1, 6, and that is L prime. And so you should notice that every shape or every point has gone 4 to the left and then 5 units up. Okay, and it should, and you should also notice that this is the same, that they are proportional to each other, which we'll talk about that later. All right, so I already did the rule. The rule's up there. It's x minus 4 and y plus 5. I think most of you are going to do the rule, whether it's vector notation or this way, rather than sitting here counting every time. And again, it's totally up to you. All right, so now we're going to talk about similar and congruent, okay? And so the way you know if a figure is similar or congruent. Congruent means the exact same shape, the exact same size. They're the exact same. These two shapes are the exact same shape, the exact same size. Similar means same shape, different sizes, meaning it's been enlarged or reduced. So these two figures are congruent. Okay. So here, this is just a little, I'm going to say cheat sheet, something, just a little putting into words how you know which direction to go. So your x coordinate, you add if it's going to the right, and you subtract if it is going left. And on the y coordinate, you add if it's going up, and you subtract if it is going down. All right, third page. So it says here to write a general rule which describes the translation shown below. So again, we're just going to kind of look at our points. You don't necessarily have to do all of them. If you want to kind of double check, you can. But I would just pick 2 points and I would just see what the rule is. Like, how did I get there? So the X is whether you're going left or right. So notice I'm going from triangle LMN to L prime, M prime, N prime. That's how I know which one I'm going to. I'm going this way because this is my pre-image and this is my image. So to get from N to N prime, I'm going 1, 2, 3, 4, 5, 6 to the right. So it's going to be X plus 6. And then I'm going 2 up. So it's going to be Y plus 2. Vector notation is 6, 2. All right, so let's look here. And it says graph these points. So we have T that is at 0, 3. We have U that is at 2, 4. Excuse me, sorry. And then we have V that is at 5, -1. So we are going to plot these points. And I know that's a terrible job of drawing my lines, but oh well. All right, and then we are going to translate triangle TUV using this rule, excuse me, right here. All right, so we are going to go 3 to the left and 1 down on each of them. So I'm going to go ahead and I'm going to kind of skip just because I know it's coming. And I'm going to go ahead and subtract these. So I'm going to subtract 3 from my X and subtract 1 from my Y, which gives me -3, 2. Then I'm going to go ahead and do U. I'm going to subtract 3 from my X and 1 from my Y. That goes here. So this is going to give me -1, 3. And then I'm going to do the same thing with V. And I'm going to subtract 3 from my X and 1 from my Y, giving me 2, -2. So I'm going to go ahead and plot these points. So -3, 2. And again, I'm going to label that. So that's T prime. -1, 3. That is U prime. And 2, -2, which is V prime. That's a terrible line. And so there you can see you have your translation. So we've drawn it, we've identified the coordinates. All right, so in words, we just moved. I kind of skipped that part, didn't I? In words, we are going 3 to the left and 1 unit down. All right, now for F, it says using the image of T prime, U prime, V prime, perform an additional translation using the rule of adding 3 to the X and subtracting 3 from the Y. Notice, excuse me, that when we write this, that there's 2 little marks here. So we call this triangle T double prime, U double prime, and V double prime. So we are going to and we're doing this with these points right here. Not the original ones, but these new ones that we have. So when I do that, when I add 3 to my X and I subtract 3 from my Y, T double prime becomes 0, -1. U double prime becomes 2, 0. And V double prime becomes 5, -5. So again, we're going to go ahead and plot these points. So 0, -1, and that is T double prime. 2, 0, that is U double prime. And 5, -5, and that is V double prime. And the question is this new image congruent or similar to the original figure? It's the exact same shape, the exact same size, it's just in a different location, so it is congruent. Exact same shape, exact same size, because the exact same thing has been done to every single point every time. You subtracted 3, added 3, subtracted 1, subtracted 3. So the same thing has been done every single time. So there's no reason it would be anything different other than the exact same shape, just in a different place. All right, and for the last page here, use arrow notation to write a rule for the given translation. So write 5 units and 1 unit up, excuse me, is going to be x comma y is going to be, right 5 units is going to be x plus 5, and 1 unit up is going to be y plus 1. It doesn't ask for vector notation, but just to show you, vector notation would be 5 comma 1. Then we're going to graph and label it. So let me go ahead and do the new points. So let me do this. Okay, so A is at -4 comma 1. B is at -1 comma 1. C is at -3, -2. And D is at -4, -2. All right, so again, if you would prefer counting, if you want to count every single time and then identify the new points, you go for it. My preference is to identify the points and then perform the either addition or subtraction to each value. So when I add 5 to the x and I add 1 to the y, these are my new points. A prime is going to be at 1 comma 2. B prime is at 4 comma 2. C prime is at 2 comma -1. And D prime is at 1 comma -1. So I'm going to go ahead and plot these. So 1 comma 2 is A prime. 4 comma 2 is B prime. 1 comma -1 is D prime. And C prime is 2 comma -1. So there you go. It should look like that. All right, number 2, same thing. Let me change some colors here. All right, so now we're doing this one here. Arrow notation, we would say x comma y. And we're going 3 units left, so that's going to be x minus 3. And 2 units down is y minus 2. Vector notation here would be -3, -2. Because since the -3 is in the x place, that's telling you subtract 3 from the x. And the -2 is in the y place, which means you're subtracting 2 from the y. So now we are going to graph and label the image. So A is at 1 comma 3. B is at 2 comma 3. C is at 3 comma 1. And D is at 2 comma 1. So I'm going to perform the translation here. So A prime is at -2 comma 1. B prime is at -1 comma 1. C prime is at 0 comma -1. And D prime is at -1 comma -1. So let me see. I'm going to go ahead and graph this. So -2 comma 1 is A prime. -1, 1 is B prime. 0, -1 is C prime. And -1, -1 is D prime. And so there we go. This is our pre-image, and this is our image. All right, so number 3, it just asks us to use arrow notation and write a rule that describes it. Again, you're just going to pick a point. I'm going to go from D to D prime. Remember, you want to go from your pre-image to your image. And so to do that, I'm going to go 1, 2, 3, 4 units right. So this means I'm adding 4 to my x. and then I'm going to go up 1 on my y, so y plus 1. In vector notation, this would be 4, comma 1. On number 4, same thing, we're writing a rule. So I'm going to go from E to E prime. So I'm going to go 1, 2, 3, 4 units left. So in vector notation, you're going to say x minus 4 because I'm going to the left. And since I'm not going up or down at all, we just say y. You could technically put plus 0 or minus 0, but you want to simplify it, and it just simplifies to 0. And so in vector notation, this would be negative 4, comma 0. Tells us we're subtracting 4 from the x, and we're not doing anything to the y. All right, so I hope this helps you. You now have some more practice that you're going to do on your own. As always, feel free to send me a message through Remind or send me an email to mathteachercoffee@gmail.com if you have any questions, and I'll try my best to get back to you and help you, all right? All right, good luck.